We're going to start this video lecture with a question we actually first asked in class, which is, how much of the moon is lit by the sun? Now, maybe you remember the answer, maybe you don't. I want you to think of what you believe the answer to be, and then we're going to go through these and we're going to identify the correct one. So, how much of the moon is lit by the sun? A is depends on the time of the month. Well, um, B is half, C is between half and full, and D is between none and half. The correct answer is half. All of these others are depends on the time of the month. Well, how much of the moon that is lit up that we see depends on the time of the month, right? And even from what we see, we know neither C nor D is true because sometimes very little of the moon is lit up, sometimes it's full. And so, to even get to what we actually see, you'd have to do both C and D to get between none and full. So you should have known those were wrong. And the only ones that were possible answers were depends on the time of the month and half. And the correct answer is half. The phases of the moon all depend on the relationship in position between the Earth, the moon, and the sun. If we look at the phases of the moon, we have our new moon. Our new moon is in the sky near the sun. Right? New moon is in the sky near the sun. Waxing crescent. Waxing crescent is going to be coming up just after sunrise. All right, it's going to be coming up after sunrise. First quarter. The first quarter is going to come up around noon and be straight overhead around, or as high as it's going to be in the sky around sunset. Waxing gibbous is going to come up afternoon, and then the full moon is going to come up at sunset. Waning gibbous is going to be coming up a bit after sunset. Third quarter is going to be coming up about the middle of the night. All right, and you'll be coming up then, and then there's waning crescent. So we go from new to full, right? Waxing means increasing. Waning means decreasing. If we look at this in this picture, what we can see is when the sun is over here and shining at us this way, well, we're seeing a new moon because we're seeing the side of the moon that's not lit up. And you can see in this picture, half of the moon is lit up in all cases, right? We're seeing the side here that's not lit up. As it goes around, right, now we're getting to here, all right, at noon, this moon is first quarter, should be rising. At noon, it should be rising. And then we get to full. So the sun and the full moon are opposite to each other. So as the sun sets, the full moon rises. And as the full moon rises, as the full moon sets, the sun rises. They're opposite to each other in the sky. Then we work our way around to third quarter. So third quarter is going to be up in the air. It's going to be rising. Let's see. When is third quarter going to be rising? It's going to be in the sky, about halfway up about noonish in the sky as the sun rises. And then slowly the moon drifts back towards the sun, and then you get to where the moon is near the sun. All right, so you get this increased separation between the moon that then starts decreasing, sun and the moon in the sky, increases, gets maximum, decreases, and we're back to the new moon, which is over near the sun. We can use the moon to tell time, right? You can tell what time of the month it is. We can tell things like that. It's moves through the sky daily because of the motion of the Earth. It also has its monthly movement. Here's another way to look at the phases of the moon. So we've got our new moon that's over near the sun, and then as it waxes, we get up to at sunset. the first quarter should be high in the sky. Or at noon, if we rotate this back, at noon when the sun's overhead, the first quarter should be rising. All right? And then we get to, as the sun sets, the new moon, or the full moon, as the sun sets, the full moon rises. If we look at it from the other way, as the sun rises, the full moon sets. And then you get to the waning quarter, the third quarter here. As the sun rises, you expect to have the third quarter directly overhead. And as you wane more, you get back to, as the sun rises, the new moon is also rising. So the newer the moon, the closer it is to the sun, the fuller the moon, the further it is from the sun in the sky. It's another view of the phases of waning and waxing. All right, so these questions. At what time does the full moon cross the meridian? Well, midnight, right? Because it's opposite to the sun. The sun crosses the meridian at noon, and so if the moon is opposite to that, it crosses the meridian at midnight. That's where we get the phrase midnight. About what time does the new moon set? Well, new moon is close to the sun, so the new moon sets at sunset. About what time does the first quarter moon cross the meridian? All right, the first quarter moon crosses the meridian as the sun sets. Right? It rises as the sun crosses the meridian. It sets as the sun. It crosses the meridian as the sun sets. About what time does the third quarter moon rise? Third quarter moon is going to rise around midnight. Right? And then it is going to be at the meridian when the sun rises. We see the same face of the moon all the time. This is why people talk about, there's a misnomer of the dark side of the moon. And what they really mean is the other side of the moon. The reality is we see the same face of the moon all the time because the moon's rotation around the Earth and the moon's rotation around its axis are synchronized so that the moon faces us all the time. It's rotating on its axis, but it's rotating so that it faces us at all times. It does this because of something called tidal locking. The tides over the billions of years have brought the moon to this point where it keeps the same face towards us at all the time. So if you were to watch the moon carefully and pay attention to the features on the moon, we'll pretend one of those is this little man standing here. As the month goes by, the moon is rotating, right? It's just rotating so that that same feature is towards us at all times. Okay. We can also keep time by the sun and the moon, right? The month is determined by the moon. This is why we have the months are about the length they are, is because those are based on the moon. Now there are two types of months, just like we talked about. There are two types of days. There's the day where we've done one full rotation, and then there's a solar day when we've come back to the sun is at the meridian, from meridian to meridian. There are two types of months, the sidereal month and the synodic month. What do they mean? The sidereal month is the amount of time it takes the moon to orbit the Earth once. This is 27.3 days. So one full circle around the Earth and coming back to where it started, 27.3 days. But you have to remember, in that time, the Earth is moving around the sun. So just like a solar day and one full rotation of the Earth are not the same thing, a sidereal month and a synodic month, the amount of time it takes for it to go through one full cycles are not the same, because the cycle depends on the position of the sun. Since over the course of 27.3 days we have moved, right? The Earth has moved around the sun. It doesn't matter if the moon has made it all the way around once. It's not yet back to the same relationship between the Earth and the sun that it was when we started. And so we call the time it takes for a full cycle of phases to happen the synodic month. The synodic month takes 29.5 days. The synodic month is what defines our canonical month on the calendar, which is why all months are around 30 days, 31 days, except for February, the odd one out. But it's a cold month and we want it to be shorter anyway. If you look at a sidereal versus synodic, right? A sidereal month has happened at the point where the moon is back to where it was with respect to the stars, right? Synodic is when the moon is back to the point where it was with respect to the sun. So sidereal has to do with its position, its absolute position with respect to the stars, and while synodic has to do with its position with respect to the sun. And the issue is we're rotating around the sun, and because we've rotated around the sun, that position is a little bit further along to reach synodic month than to reach sidereal month. Now, if we rotated the other way, or if the moon rotated the other way, the synodic month would be shorter than the sidereal month. Again, this all speaks to moon phases, right? And you can see here, this illustration gives us the angular difference between where the moon is here versus the moon here when it reaches a new moon. Okay, that's it for moon phases. I'm going to make a second video around eclipses.